Hello friends, in this lecture we discuss construction of Turing machine with example 1. Okay, so here this is the procedure of constructing any of Turing machine. This is the uh, this is the 7 step, and from step 1 to step 7 we will learn how to step by step we construct a Turing machine. So very first, for any Turing machine we have to think the logic of the design. So means how we can solve a particular problem. Okay, so overall we have to think the solution. Okay, and after the solution we are trying to we start the designing process. And during the thinking of the logic, we should think about some strings which are belongs to or not belongs to the given language. Okay, so that gives us clear understanding of a particular problem. So after this step 1 and step 2, we set initial instantaneous description. Means what will be the our initial state, and and a particular strings that maybe belongs to or not belongs to, and so accordingly we proceed further. Okay, so generally we take a string which is belongs to and make the initial instantaneous description like this. This is our initial state, and we are making some string like this. So suppose this is our input string. So this is actually instantaneous description, and further from this input string there is a by default tape symbol blank, and before this there is also a by default black symbol. So like this we design our initial instantaneous description, and from this initial instantaneous description actually the construction of Turing machine is started. So here the main step is making the transaction function. So so the in step 4 that gives us that tell us repeat step 5 and step 6 until we reach to the halting state. Okay, halting state is a state at which we don't found any suitable further transaction to move in a Turing machine. So a halting state is actually uh, sometime it is a accepting state or sometime it is a rejecting state, both. Okay, so we have to repeat step 5 and step 6 until we reach to the halting state. And in step 5 we are trying to design a transaction function corresponding to the logic, means a solution or a design for a particular problem. So, so these transaction functions are designs further, and idea of designing this transaction function is always comes from the transaction sequence. Okay, so these step 5 and step 6 are working simultaneously. Means we have a uh, current situation according to the problem, and by that current situation we think what should we do further. So actually by that we design our transaction functions. Of course we take our examples uh, during the solution of a problems as an example. Okay, so think that so understand that this step 5 and 6 are very important, and both of these two are working simultaneously. Okay, and next whenever the halting state is reached reached and a halting state is a final state, or we can say accepting state, and then we declare the computation is successful, and we design all tuples corresponding to the transaction function for a Turing machine. If we halt at a non-final state, means at suppose at any non-final state our machine is halt, means no choice to move further, and we can say not a suitable input is received or read at the input tape. On that situation we can say the input which is we assumed is not corresponding to given problem or corresponding to given language. Therefore for that we cannot construct a Turing machine. Okay. Okay, therefore, or therefore, this halting state is a state of declaring rejection of a particular input. Okay, I hope this is clear. Actually, the overall computation or construction of a Turing machine is described in these 7 steps. Now we discuss this step one by one for constructing a Turing machine. So let's take one example. Suppose we have to construct a Turing machine for language L1, and language L1 is a set of all strings over a sigma 1 that having the even number of ones. So first of all we assume some string. Suppose x1. X1 is belongs to L1, so it having the even number of ones. Okay, even number of ones. There are 4 ones. So this string x1 is belongs to L1, and this string x2 having 3 ones. So therefore this x2 is not belongs to L1. Okay. Now we think for a logic. Of course, this is very simple logic. We know in any string of ones only, uh, the number of ones or occurrence of one is an alternative sequence of odd and even. Okay, and that start with odd number of ones. After that, even number is come after odd and even, like this. Okay, so we start to design a Turing machine like this. At state Q0, whenever we read odd number of ones, we move to state Q1, and from state Q1, if we read again 1, then we move to state Q0. Okay, so whenever we are at state Q0, it means the even number of ones have been read out. Okay, so it is very simple. When for any string of ones, if we move or we process, then if the string having even number, then we stop at state Q0, and that is we make our accepting state, means a final state. So input is accepted if we reach to state Q0, and this is non-accepting state, means whenever we are at state Q1, it simply means that we have been read until odd number of ones. So when we read this one, then we move from Q0 to Q1. Then when again for this one, we move from Q1 to Q0. For this third, we move from Q0 to Q1. And this fourth one, we again move from Q1 to Q0. So this is, I think, clear. So this is the logic of this particular problem. Okay, and these are our input strings also. For this language L1, both these things, logic and assumptions of input strings, are very simple. Okay, but but for some problems it's may very complicated. So if we want to construct a Turing machine for any of the problem, then first we have to think how we can solve that problem and try to make the local computation. Okay, and think some strings, those are belongs to or not belongs to by that language. After that, we should try to start making transaction functions. Okay. So at step 3, we set our initial instantaneous description, that is Q0, and our string X, which is belongs to our language L1. Okay. So this is snapshot of Turing machine. This current state is Q0, and this is reading very first element or a symbol of your input string sigma. This is our sigma. Okay. And this is totally a tape symbols. So initially, this is in initial state Q0, and it is reading uh, very first symbol in an input string. Okay, so this is initial instantaneous description, and we can write this in a alpha beta gamma format also. Let us move to the next slide for other steps. Now step 4 is telling us repeat step 5 and 6 until we reach to the halting state. Okay, so step 5 is what? Making of transaction function. Here we I already write all both of these transaction, but we write this one by one as and when it is required. Okay, so just think over it and start with initial instantaneous description. Okay, so assume we just have this. Okay, forget all other things over this slide. Okay, think we just have this thing. Okay, so we have at initial state Q0, and we're reading first input symbol. Okay, and that is enclosed by the default symbols, you know, default tape symbols. Okay, this blank and blank, you can imagine there are lots of blank, but there is no need to write all those because those are infinite. So we just take these two here and one here. You may take one or two more if you like, otherwise there is no need. Okay, so think just over this, and and this telling us we are at state Q0 and we're reading first one. So what we have to do in this situation? Of course, we know according to the step 1, the logic. So by the logic, uh, we have to process this one and move to its right hand side. And processing means of this one process of this one means we may change this into any default symbols. Okay, so we change this by a blank. Okay, so we change this one by this blank and moving to the right hand side for the next one and change our state. Okay, like this. So for this we have to write a transaction function. So now we write a transaction function like this. Suppose that is, whenever we are at state Q0 and we're reading 1, then we move to next state Q1 and overwrite the 1 by blank symbol and move to the right. Okay, so this is, I think this is understand. So we write this transaction function delta 1 corresponding to this instantaneous description. I hope it is clear. Many people think we have applied this transaction function at this, but the thing is different. According to this situation, we have to construct this transaction function. Okay, so if you understand this procedure, then there is no any difficulty for constructing of any of Turing machine. You just know the logic how to construct a Turing machine for a particular problem. After that, you are able to construct any Turing machine. Okay, so next, now the current instantaneous description is this, and this situation is again what? We are at Q1. Okay, so one question has come into your mind: why we change this state? We change state only when we have to remember something. Okay, means a machine have to remember something. Okay, So so the changing of state from q0 to q1, it tell to the machine, or remember, or tell to the machine that this time it is reading the the even number of 1. Okay, when the machine is in q0 and that read of one that read the 1, then it simply means that that 1 is the odd ones. Okay, odd one. Okay, that one is odd one. And when the machine is in state q1 and it read 1, it means it reading even number of ones, simply like this. Okay, whenever machine is in q0 state, it is reading the 1 which is odd ones. Okay, and whenever the machine is in state q1, it reads the even number of 1. Okay, so corresponding to this situation, we have to turn again to the new state, means change the state, because next time we will read the odd number of ones, so state should be changed. So q1 to q0 and moves to the right hand side. Okay, move to the right hand side like this here, and state should be changed, because next time at q0 we will read this one, that is odd number of ones, and change this one by blank, because it is already processed. So for this, we write this transaction function. If whenever we are at state q1 and we're reading 1, then we change the state from q1 to q0 and overwrite 1 by blank and move to the right hand side. So according to this situation, uh, we had return write this transaction function. Okay, hope you understand this. Now again, we are at this situation, by applying this delta function delta to we have in this situation. Okay, again we are at state q0 and we're reading 1. It means this one is odd number of 0. And for this situation, whenever machine is in state q0 and it reads 1, for this situation we already have a transaction function, that is equals to transaction function delta 1. So we apply again that same delta 1 and move to this situation. Okay, we move at this right hand side and process this one by overwriting blank. Okay, like this. So we come to this situation. Again, for this situation, whenever the machine is in state q1 and it read 1, then for this we have a transaction function, that is delta 2. Okay, so again this one is override by blank and this q1 is moved to this side. Okay, before this blank, and make the uh, and change its state from q1 to q0, like in this situation. Okay, so after processing this whole input string, the next situation is this. Okay, in this situation, the machine is in state q0 and it read blanks. It simply means that, and this situation is occur occur first time, and that indicate that the input is processed. Okay, input is processed, and the input is processed, and if that is in state q0, it simply means that the input is processed. And it has another meaning also, because for q0 and b means the current state is q0 and the current input type symbol is blank, and for this situation we don't have any transaction function. Okay, we don't have this situation into the transaction function. Look at this side. Okay, so this is indicating halting situation. Okay, and halting when your input is processed and halting at final state, because q0 is your final state. Okay, we mark this as a final state because here we are designing actually. So we mark this q0 as a final state. So halting at final state gives or tell us the computation is successful. Okay, because whenever we come to this situation, that is what that is what accepting of the input strings. Okay, when your suppose when your input is null, okay, on that case you reading what, you reading your initial state is q0 and you reading what, first blank. This is also accepting because the null is representing even numbers. Okay, when 0 representing even numbers, actually the things which is comes before even sorry odd number is always even. So uh, so so the uh, so the come before this one is what, even number of even number. Okay, like this. Actually this is not the this is the concept actually of even and odd. I hope you understand this. Okay, like this we make a transaction function, and this transaction function is understand in the transaction diagram format also. We started at q0. Okay, and if we read one, okay, if we read one, then move right hand side into the transaction sequence. Okay, this direction right hand side is used in the transaction sequence. Okay, not in this transaction diagram. Okay, so we move right hand side in the transaction sequence and override this one by this blank and move to the next state q1. That is what telling us a transaction function, because this q0 is indicating what, this q0, this one is what indicating this one. Okay, next state is that q1 representing this, and the overhead symbol, this blank is representing like this, and this r is corresponding to this r, like this. So this is transaction function, and this is, sorry, this is transaction diagram, and these are transaction functions. Now we take one another string x2, that is triple one, and of course this is not belongs to L1, so it should be rejected. After applying this transaction function delta 1 and delta 2, we reach to this situation. Okay, so now machine, and the machine is in state q1 and it read blank. For this special situation, we don't have any transaction function. Okay, look at this. We have q1 and 1, means the current state is q1 and reading input symbol is 1, but we have we have no any choice when the machine is in state q1 and it reads blank. So this is a halting situation, and halt at non-final state, that is in q1, it simply means that the the processed input is not belongs to your machine. So we can say our this machine having these two transaction function make the universal machine. It means all the input which is belongs to L1 is accepted only, and all the input which is not belongs to L1 is rejected. Okay, so our machine is universal. Now now after this we design all the tuples like this. Okay, this is this set of state where we have q0 and q1. This is toss tape symbol. The one and blank is written over the tape. Blank b is used for default tape symbol, indicating the absence of input symbol sigma, and sigma is 1. The input is written over only 1. q0 is initial state, and q0 is initial state, and of course this q0 is our final state. Okay, so please make it correct. And delta is transaction function which is either given in this format, a transaction diagram format, or in transaction table format, or as written in previous slide, in a transaction function format. So any of these format you can use. So this is the construction of transaction. This is the construction of Turing machine. Hope you understand. Thank you for watching this video. If you have any doubt, then please contact me. The reference of this lecture is K.L.P. Mishra and Sudkem, Peter Lange, and Michael Zipper. Thank you.